Hello students, I hope all of you will be fine. So today we are going to solve this assessment problem 3.8 in your book, in which we have to find out the value of this voltage V, in which we are given a 2 ampere source, and there is this circuit which seems like a very complex circuit. So here we can see that we basically the resistors are connected neither in series nor in parallel configuration. So this is rather a very complex configuration, so we have to sort it out, and then we have to find the value of V by finding the equivalent resistance. After finding the equivalent resistance, we can easily find out the value of the voltage by the Ohm's law. So let's go towards the circuit and let's demystify this circuit. So this circuit can also be drawn like here. This is also like a diagram of this circuit. Okay, this one, this one. So this is basically the same circuit, in which this is the 28 ohm resistor, this is the 20 ohm resistor, 10 ohm, 5 ohm, and then 105. I'm not writing the omega unit or symbol with these resistors for my own convenience. So if you are confused here, so just remember that there is an ohm sign here, okay, omega sign here. So this is the current source of 2 amps. So we can see here that now we have two configurations here. The one here is this delta 1 and the other one is this steric one. So you can convert any one of these two configurations into the other configuration, and you will see that the circuit will become way easier for you to solve. So now here let's solve it for this delta circuit. So now here we have this delta circuit. Let us change it into the star configuration. So for a star configuration, we will have the resistors in this configuration. Okay, so let's say this is resistor A, this is B, and this is C. So this is now our configuration. So in order to find the value of A, we know that in the denominator we will write the sum of all the resistors in the delta configuration. So these resistors are basically 20 plus 10 plus 28. So these are basically our resistors which are in the denominator, and similarly we have to write the product of all the two resistors which are connected with this junction. So at junction A, at this junction where A resistor is connected, we have two other resistors in the delta configuration, which are 20 and 28. So writing 20 and 28 configuration here. So by solving it here, 560 divided by this is 58. So this sum will give me 9.66 ohm. Okay, I have calculated it earlier on. So similarly for B, this is the B resistor, the denominator remains the same and the sum of it will be 58. But for B, we have now two resistors, 10 and 20, which are connected with this junction where one end of the B is connected. So it will become 20 multiplied by 10. So solving it 200 by 58, and it will give me 3.45 ohm. Similarly for C, denominator again is the same, which is 58, and the product of 28 and 10 will be written because at this junction 28 and 10 are connected. So 28 multiplied by 10, this is 280 by 58, and ultimately the answer of it will be 4.83 ohm. So now we have find out the value of A, for B, for C, and this is the configuration we can sort out. So when we have converted it into the static configuration, we can easily remove all the delta resistors. So let me remove the delta resistors and see how the configuration will become. Sorry, just removing this. Okay, so now you can see that this is the configuration which is now we have obtained. So after it, we can easily convert it into the form which is this one. These are our resistors and this is our source. Okay, so this is our 2 ampere source. This is our resistor A, and the value of resistor A is basically 9.66. This is resistor B, which is basically 3.45. This is the 5 ohm resistor. This is C is 4.83, and similarly this is the 105 ohm resistor. So this is a very simplified configuration, and here we can very easily find out the value of equivalent resistance because now we can see here that this resistor and these two are in series, these two are in series, and writing them in series, and at the end solving it, we will easily calculate the value of this voltage which is here. So again, simplifying it, while simplifying it, it will become these two resistors are in series, so writing a series resistor here, and similarly these two are again in series, these two, so the equivalent resistance here is in series, these two will be added, so 5 plus 3.45 will be 8.45. Similarly 105 plus 4.83, because two are in series, it will become 109.83. similarly this is 9.66, and this is the source. Okay, so then let us convert them again, because now 8.45 and 109.83, these two are in parallel combinations. Okay, these two are in parallel, so their R prime will be equal to 8.45 multiplied by 109.83 whole divided by 8.45 plus 109.83. so solving it for R prime, it will give me the value 7.85. This is the equivalent resistance of these two parallel resistors. So this is now 9.60, 9.66, and this is that equivalent resistance which is R prime, and we have found its value which is 7.85, and the source connected with this one is again here 2 amperes, and simplifying them again, because now in 9.66 and 7.85 are in series with each other, so this will give me an equivalent resistance R equivalent. Okay, and this will be the summation of 9.66 and 7.85, so it will be 7.51. okay, and the source current is 2 amperes. Now we have to find out this value, which is the voltage here. So we can see here that we have only just one source and one passive element. All the voltage which is generated here is basically consumed by this resistor, therefore we can easily find out the value of this V. So V is equal to I into R equivalent, and the value of V is therefore I, the value of I is 2, and the value of 7.51, so it will give me the value of V, that is almost 35.01, which is almost equal to 35 volts. Let me write the unit here. So this is 35 volts voltage value which we have obtained from this circuit. So this initially this circuit was very daunting to us. We have converted it into the static configuration, and then after finding out the equivalent resistance, we have found out the value of voltage.